6-4, elimination using multiplication. Our objective is to solve a system of equations by elimination, but you must also use multiplication. So yesterday, the equations were basically ready to add and subtract. The coefficients of either the x or the y were already set, either the same or opposites. Okay, so today's, they're not quite ready. You have to do a multiplication first. So you're going to add or subtract after multiplying one or both of the equations. You want to get a set to be opposite, either the set of x's or the set of y's. You want them to be opposites, okay? So just like yesterday when they were the same, I told you go ahead and multiply through by -1 to make them the opposites because it's easier to add than it is to subtract like that. So on these, you're going to go ahead and set them up as opposites right away, so you don't have to go back and change all the signs. So let me explain. Our first example, 2x plus y equals 23, and 3x plus 2y equals 37. So what you're going to do is you definitely want to get by with the least amount of multiplication as you can. So if you can get by with just 1, then you definitely should just go with 1. You'll look at the coefficients in which one of them is a multiple of the other. If that happens, then you definitely can get by with just one multiplication. So if I have 2x plus y equals 23 and 3x plus 2y equals 37, this is set up perfectly for me to do just one multiplication. It would involve multiplying this top equation by a -2. If I multiply the top equation by -2, then it becomes -4x minus 2y equals -46. And I write the other one as is below it, 3x plus 2y equals 37. Did you see what I did there? I made the y's opposites, didn't I? So now I'm ready to add. The y's are going to fall out. -4x plus 3x would be -1x. And -46 plus 37 would be -9. You never end up with the negative variable, so you definitely divide by a -1 if necessary, and x is 9. That is half of my solution. Now I need to find the y. So I'm going to go back up to the original top equation. That looks like the simplest. And I would go 2 times 9 plus y equals 23. 18 plus y equals 23. Subtract 18. And y equals 5. So my ordered pair would be 9, 5. Yes? It's just like last night once you get a set of the x's or the y's to be the opposite. It can be either one. And then you just add them together, solve for one, plug it in, get the other. Ben? No, it doesn't have to be the y. It can be either one. It could be either one. You could multiply either one. Now you're going to get to a point where you might have to multiply both, and I'll do one of those in just a minute. Yeah.
So they'll come out the same?
Yeah. No matter which way you do it, it's going to come out the same. Because look at the next one. X plus y equals 2, and -3x plus 4y equals 15. Well, since the x and the negative 3x are already opposite signs, I'm just going to multiply the top one by 3. So this time it'll be the x that I'm dealing with. So 3x plus 3y equals 6. Here's the most common thing that people forget to do though. You see how I had to multiply through the whole equation? 3x and 3y and 6? I can't tell you how many times people multiply 3x and 3y and then put equals 2. Don't do that. Please make sure you multiply the whole thing. Write the bottom equation as is. Negative 3x plus 4y equals 15. Okay, the x's are now gone. 7y equals 21. Divide by 7. Y equals 3. So I have half of my solution, and I'm going to go ahead and put 3 in place of y. So x plus 3 equals 2. Subtract 3 from each side. X equals negative 1. Questions? You see where we're going with this? You have to multiply by whatever makes either the x's or the y's the opposite. If one is a multiple of the other, that's the one you're going to multiply, the one that's that is like the factor, I guess, of the other one. Okay? So like 1 is a factor of 3. That's why I multiplied the top one by 3. All right. Let's go down to the next example. 4x plus 3y equals 8. 3x minus 5y equals negative 23. Okay. Neither one of those is a multiple or factor. I've got 4 and 3 on the x's. Nope. No multiple or factor there. 3 and 5 on the other one. Nope. No multiple there. But I will tell you this. Since my y's are already opposite signs, that's the ones I'm going to target. So you look at 3 and 5. What's the least common multiple of 3 and 5, Megan? 15. So that means I'm going to take the top equation by 5 and the bottom equation by 3. Is that what you thought? Anybody not understand why I picked 5 and 3? Because now my y's are going to be 15 and negative 15. Ben?
Why couldn't you just multiply the top one by 10 and then the bottom one by 6?
10 and 6. Where are we getting 10 and 6? Oh, I could have. But why don't I go with 5 and 3? They're smaller numbers.
Could you also do 4 and 3?
Sure, you could have done 4 and 3, but that means that one of them you're going to multiply by is going to be a negative, and you know there's so much of a chance of making a oops there. Okay? So since the y's were already opposite signs, that's why I picked that. Okay? And 10 and 6 would work, Ben, but why go with bigger numbers? You're better off going with smaller, less chance of a mistake, I think. Okay, so then multiply through the top one 5, so 20x plus 15y equals 40. 9x minus 15y equals negative 69. I'm ready to combine those. 29x, the y's fall out, equals negative 29. Divide by 29, x equals negative 1. So that is half of my solution. Put negative 1 in for x. And now I think I'm going to go up to the top one. 4 times negative 1 plus 3y equals 8. So negative 4 plus 3y equals 8 plus 4. 3y equals 12. And divide by 3. Y equals 4. Negative 1, 4. Okay, questions about that? All right, we've got a word problem to do. Has everybody got the red written? Seven times a number plus 3 times another number is negative 1. The sum of the two numbers is negative 3. What are the numbers? So I'm going to let x equal my first number. And let y equal my second number. So 7 times a number, 7x, plus 3 times another, 3y, equals negative 1. The sum of the two numbers is negative 3. What's that look like? X plus y equals negative 3. What do you think the best way to go about this would be? The best way. The best way. Tyler, what do you think?
X plus y would be 3 times negative 3.
That's exactly what I would do. Take the bottom one times negative 3. Since you're going to have to multiply by a negative anyway, go with the smaller amount and make the y's the opposite. So here's what I'm going to do. I'm going to come over here and write the top one as is. 7x plus 3y equals negative 1. And then take that bottom one and write it down below it. Negative 3x minus 3y equals 9. Okay, combine them together. The y's fall out. 7x minus 3x is 4x. Negative 1 plus 9 is 8. Divide by 4, x is 2. That is half of my solution, so 2 something. I'm going to go into this bottom one and put 2 in for x. 2 plus y equals negative 3. Subtract 2. Y equals negative 5. My solution, the two numbers are 2, negative 5. I wrote it as an ordered pair. There's nothing wrong with that. You could say the numbers are 2 and negative 5, however you want to do it. Okay. Questions about that? You're going to have to multiply at least one of the equations. You want to get one set, either the x's or y's, to become opposites. Okay, you want them to become opposites. Pick one and go with it. Once you find one, go solve for the other.